granites, and they'll measure the amount of uranium in the rock, and then they'll measure the end product of the uranium decay, which is lead-206. And so they say, well, if we've got slow lead accumulation, that assumes the Earth evolved from chaos over billions of years, and the uranium decay rate was unaffected by any unusual events in Earth's history. In other words, they assume that indeed if uranium is decaying at the same rate that it is today, they've got a certain amount of lead and a certain amount of uranium, just like water dripping into a bucket, provided you don't turn the spigot up, they can use that as a clock. So this whole idea of the age of the Earth is dependent very critically on this whole idea of uranium and the other radioactive elements decaying very, very slowly at their current rate. But the question is the following. First of all, how do the polonium halos provide any evidence at all contrary or agreeing with that? Well, indeed, if you've got primordial polonium halos, as we've already said, then what happens to all these billions of years of granite formation evolving? What happens to it?
Collapses the time frame.
It collapses it to what? Almost nothing. You don't have any time for the ancient rocks to begin to cool and for the radioactivity to begin to decay very, 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 very slowly. As David has said earlier, at the top schematic there, that's the usual uniformitarian way of looking at things. You've got radioactive decay, slowly cooling molten granite. But indeed, because you've got the primordial polonium in there, you wouldn't have any halos if it was slow cooling of the granite. The only way it's going to happen is for the granite to have been created instantly along with the radioactivity and the particles to shoot out rapidly to form the halos. So, now it turns out, David, if you want to go ahead and pick up.
You know, we've been talking a lot about polonium halos, but what about the uranium halos? We actually showed a picture of a uranium halo last night. They have a lot more rings than the polonium halos. There's more alpha decay steps from the uranium-238 to the daughter product lead-206. Evolutionists claim that they take hundreds of millions of years to develop these uranium halos. What they don't realize is that they are actually coloration thermometers that tell they could not have developed slowly under the assumption of a constant decay rate and hot conditions deep in the Earth. Why is this? It's very simple. Remember, halos cannot form when the rock is molten. They not only cannot form when the rock is molten, they cannot form when the rock is even hot. So the rock has to be in a cooled state. So if you have a fully developed uranium halo, that in itself is an impossible event, assuming a constant rate of radioactive decay of uranium, and several million year half-life, because you cannot propose that that rock has been sitting there with the uranium halo forming for millions of years, because the rock in its lifetime must have been heated to a very high temperature. Anytime that rock was heated to a very high temperature, what happens to the record of the halo? It's gone. So you have to have a uranium halo. You have to hypothesize, how did that uranium halo develop? In this case, it has a long half-life, which you would think, well, that fits the theory of evolution. That doesn't help creation, but it really doesn't make sense in an evolutionary framework either, for a different reason. The different reason being that if it was theorized to form deep underground in the hot environment of the molten magma, then the halo would have never formed just from the sake of temperature alone. Not from the standpoint of half-life, but from the standpoint of just the physical conditions necessary for halo formation.
Let's continue. Let's look at this schematic here one more time. Again, what we're saying is, miles in the Earth, we've got this big blob of molten melt, granite melt, and it's going to supposedly, this is now the usual evolutionary way of looking at things, of course. David has already mentioned that. After many thousands of years, it begins to cool from the outer periphery inward, cool, slowly, slowly, slowly. Then after many millions of years, 50 million years, 100 million years, you finally got, a pool of magma supposedly at the beginning over there on the left, finally cools. That is the way that supposedly El Capitan came into existence according to evolution. In fact, if you go over there, I'm told you'll see signs to that effect. It's hundreds of millions of years old or whatever, deep in the earth for a long, long period of time. And then the reason we see it as it is right now is because it was pushed up in recent geological history. Well, what David has got through telling us here is that here's the uranium halo. That supposedly took, according to evolutionary theory, it's one in my own collection, I see it and so forth, analyze it. It took about several 100 million years, 500 million years to form as a result of the slow uranium decay. But here's the situation, as David had just said, that indeed, I've also analyzed granite cores taken from a deep drill hole in New Mexico, Fenton Hill. And you can see on the left-hand side the feet as the drill core went down. On the right-hand side, the temperature corresponding to the levels, the depth levels, so to speak. And you can easily see, of course, at 3,148 feet, the temperature has already gone up to 105 degrees centigrade. 7,115 feet, it's now at 115 degrees centigrade. 9,508 feet, 197 degrees centigrade. 12,885, 277 degrees centigrade. 14,131, 313 degrees centigrade. 3 times the boiling point of water. The interesting thing is, when I was examining these core samples, I extracted the zircons from them and looked at the thin sections of the granites under the microscope. Guess what I saw about the way in which the coloration of the halos looked? At the surface, they looked just like you saw in that last picture, the uranium halo. Very, very well developed. The coloration was full. But guess what was happening as we went down? Well, it didn't take long. At 3,148 feet, 105 degrees centigrade, the halos had begun to fade considerably. And by the time we get down to 7,115 feet, 115 degrees centigrade, virtually all gone. The annealing had taken place so rapidly at that point. There were no halos. So below that, 197 degrees, 277, 313 degrees, no halos. Now keep that in mind. Just down 7,000 feet or thereabouts in this particular point, the temperature 151 degrees, the halos were almost all annealed. What is going to happen then below that? Nothing. Could halos form even below that temperature? The answer is no, as you were saying. So what do we have? Go ahead, David. You've already said it. Maybe you just want to summarize it again.
Yeah, we've already said pretty much what's in this slide here.
They could only have formed in rocks that existed about the present temperature. In other words, instead, the uranium halos could never have developed if all the granites had cooled slowly from a hot melt over eons of geologic time, because the higher temperatures existing deep in the crust would have erased them. Remember, the geological theory says 1,000 degrees, 900 degrees, 800 degrees, that's when supposedly the granites begin to form. 500 degrees. There's no way any coloration at all will develop, and yet that's exactly the way supposedly the geologists think that the uranium halos form. Deep in the earth, hot. No way. It would not have had any halos whatsoever. What we have here is a situation where the only way you can have those uranium halos in the here and now is that they developed at essentially the temperatures they are right now, and that the decay process took place more rapidly from some event, some unusual event in Earth's history. Now, we're going to continue here and say there's confirmation of what we're saying, very specific confirmation, again from material taken from the Fenton Hill drill site. Now we're going to look at this again. Here we have the different temperatures, as we have seen before. I took granite cores from each one of those slices, so to speak, and this time took the granite cores and separated out what we call the zircons. Zirconium silicates, and have a little bit of uranium, and so therefore, these are the zircons, microscopic zircons, taken under polarized light, and these form the basis then of the experiments we're going to tell you about right now. David, tell us a little about this. Is now a single zircon crystal, and our friend Russ Humphreys has got this diagram for us. Tell us what it's basically saying here.
Well, you have the whole nuclear decay process happening within the zircon, and with each successive nuclear decay, you have the alpha particles or the helium nuclei being emitted from the radio centers of the halos. So you have an accumulation of helium within the zircons. So what you can actually do is measure the retention of helium in each zircon and then determine what you would expect the helium retention to be on the basis of evolution and compare that to what the data actually is when you go to each various level, and you can make a determination as to whether or not the data fits in anciently evolving Earth.
The next chart shows the temperature rises to over 3 times the bottom to the boiling point of water. We've already seen that at the bottom of the hole. What was of most interest as far as the age of the granite was concerned is the very high retention of helium in tiny radioactive zircons, even at the very high temperatures. Let's see if we can get an idea of basically the principle, the theory behind what we're going to be looking at. Suppose we had a picture of the Fenton Hill site here just a minute ago. Let me run back to that real quick like there. David, we're just going to make an imaginary experiment here.
Are we going to talk about the dinosaurs tonight?
Pardon?
Are we going to talk about the dinosaurs tonight? I promised somebody last night we would.
Okay.
And I don't know if we have time.
We got to do all this. We got to do everything. Okay, we're going to do it. Okay, if time is running out, then we'll make time. Okay, however it needs to be done, we're going to do it. Anyway, it's important for everyone to understand. We're at the top of the drill here. I've got a bucket of water full, and I let it down at the bottom of the drill hole. But I don't tell you how long I keep it down there. You come in after the day is finished and so forth. Initially, it was full of water. And when you see it, when it comes back up, I tell you it's 90% full. Now, would you say it's been there for 10 hours, 5 hours, 1 hour, or only about 10 minutes? What would you say? How long has it been down there? Let me do it again. Let me do it.
No, let me try to say this another way. If you have the zircons containing this helium, and your model of the Earth is that the Earth is old, and you dig up these these zircons containing helium, and they still retain too much helium, too much for evolution to explain, what do you have? You have evidence for a young Earth. The reason why is because, just like he was saying, it's the same principle that if you were to lower a bucket of water in a deep hole, you'd have so much steam and so much heat that it would boil that water away very quickly. So if you were to lower a bucket of water down deep in the earth and pull it out and no water is left, well, obviously you've left it down there quite a while. But if you lower it down and you pull it out right away and there's still water there, then you know the water hasn't been down in that hole very long. That's the same exact thing that's happening with the helium zircons. The core samples were collected, the zircons were separated out, the helium was measured, and it turns out that the amount of helium that was measured in the zircons was too great to be explained on the basis of an ancient Earth. And so basically we have 2 lines of evidence. We have the line of evidence from the polonium halos, which shows that granite cooled rapidly, was formed rapidly. Then we have the evidence of a young age of the Earth from the retention of helium in the zircons. You wouldn't expect much retention of helium in the zircons because evolution says the Earth is old. And so in fact, most of these deeper depths, you shouldn't have any helium in the nuclei of these zircons or within these zircons. But in fact, you still see...
This particular chart right here simply says, you can see the dots above, the half circles there represents the helium in the zircons to begin with, and you can see the dots over there to the right.
More dots means that it's boiling away faster.
Now,
so the deeper you go, the faster the helium's boiling out of these zircons.
Now this chart actually shows what was found, that indeed the actual circles are all gone there and very, very deep, and then at 197 degrees centigrade, only a tiny bit left, and then of course closer to the surface you've got still quite a bit there. So differential retention of the helium was the result of, indeed, the zircons being at high temperatures, and it got to the point where the temperatures were enough so that, indeed, it's all gone later on. Now, that is basically the analysis. That's what the experiment showed. Now, on the left-hand side over here, what do you expect to find on the basis of a long age of the Earth, billions of years? Only a tiny bit of helium, even there at the very surface, at 3,148 feet. What we found is some helium all the way down almost to 277 degrees centigrade. So what that means is it could have only been down there. Those zircons at that temperature could only have been down there a relatively short period of time, and that was published. I published that